So this is the cool car physics problem where you have a car that really accelerates well, and of course there's fuzzy dice hanging from the mirror. And when you're accelerating, you notice that the fuzzy dice make an angle of 20 degrees relative to the horizontal. So that means that there is a force of tension involved. Those fuzzy dice are hanging by a string, and the force of tension is holding those dice up against gravity, and they're also accelerating your dice along with your car. So this is this non-inertial frame of reference where your dice look like they're being affected mysteriously by a force, but in fact in your frame of reference it's accelerating, and so the dice are just doing what they should do, trying to not accelerate. Okay, so this is the force of gravity here. The force of tension is going to be, this component of the force of tension is going to be competing with gravity. And this is the force of tension times the cosine of 20 degrees. And so that's going to be that component. And this is going to be the force of tension times the sine of 20 degrees. And so we know what that component is. All right. This component is going to be opposite but equal to gravity. So force of tension times cosine of 20 is going to be equal to whatever the mass of those fuzzy dice is times the acceleration due to gravity. That's the component that's holding it up against gravity. And of course, the force of tension times the sine of 20 is going to be equal to the mass times the acceleration. And you might be able to see exactly where this is going, because you'll notice that this component is going to be proportional to this component based on the mass. In other words, even if we have more force from gravity, it's going to require just as much force to accelerate those dice in a particular direction. And so the mass will be independent. Okay, we were asked to find out what the acceleration is here. And what do we want to do? Do we want to go force of tension? What should we isolate from here? Acceleration, mass, or what about force of tension? Yeah, we could do that. Yeah, we could isolate the force of tension. Okay, so we know the force of tension is going to be the same for the calculation of both these components. Force of tension here is equal to the force of tension there. And so I can say that m times g times cosine of 20 is equal to m times a over the sine of 20. Now, what's going to be nice is that these masses are going to cancel out. And so the acceleration of the car is equal to the sine of 20 over the cosine of 20 times g. Or the acceleration is equal to the tangent of 20 degrees times the acceleration due to gravity. So I don't really know what the tan of 20 is, but I know how to calculate it. Times 9.8. 3.56 meters per second squared. Wow. Maybe that's fast. I'm not sure.